Okay, let's get started. Okay, any questions? Okay, I believe not. So let us start. I just first quick go over VLearn. So when you go to mathematical methods of physics is a course title. You have a course calendar which has everything here. So you have interaction which is given group wise. There are 9 groups made, so each with the 20 minutes, everything is arranged here. You will have to use VLearn calendar. Otherwise, you will find it hard to manage. So once you figured out which group you are in, so you simply press that calendar thing, and then you can see more details. And then you have a link to Google Meet, and there where we'll be meeting. VLearn, and then group is shown. The books are given, only 2 currently. That would be suffice to start with. We converts, we will be starting complex analysis. We will go to Hilbert space and vector spaces. After that, we'll get used to some complex numbers which you familiar with. Calendar information you can see, that is fine. Group 1, 2, 3, all the timings are there, but it goes to my calendar, Google Calendar. And then when you press on to the specific event, you can see Google Meet. Okay. Each of these 9 groups have a different Google Meet, and then you can join the meeting and so on. All this mathematical physics, I usually show this one lecture on what is a philosophy of mathematical methods, or rather what you should be doing and what should be your attitude towards this course, because this essentially is an attitude, not really anything else. Way to solve a problem, what is the difference between mathematics and mathematical methods, and how we actually come to solve a realistic problem. This course is not really treated you as students who want to learn something. It is really is like a kind of a ability or attempt to solve problems in general. With that philosophy, the course sometime later might get involved with the topics, and we might lose track of philosophy, and all that thing could happen. But it is important to understand what mathematical physics stands for, and how we can really incorporate this in this course. So let me show some slide here. We will discuss what should be the attitude, or in general what is mathematical methods of physics, or in short, mathematical physics subject is about. Okay, so I usually show this small presentation. There is a large difference between the way mathematicians do things and the way physicists do things. And that is what we call the difference between the mathematics and mathematical method. You might have already done some courses in mathematical methods, and you might have already done some course in mathematics itself. So you see there is a vast difference between the two. So that is basically is a highlight of this presentation. So when mathematicians, at least they think that the mathematics or the subject is logical, rigorous, and systematic. These 3 are the basic, the building blocks of mathematics. It is mostly algorithmic topic in which you systematically build, logically develop, and everything is a rigorous and systematic. Now, this is a misconception. The mathematics is all about the first line. The second misconception, most of the mathematicians have, they think that the mathematics is studied for its beauty and elegance without worrying about application. This is what in mathematician take pride of, thinking that what they call themselves pure. As far as I am concerned, I think it is just an illusion to keep ourselves up and to say that it is something which we indulge in pure things. Even applied things can be pure, and sometimes it is good to have an application or to show the usefulness of something which we do. It is not necessary that everything you do should have a usefulness or application, but one should not worry about application. And for mathematician, mathematics itself is a god. That is what they are dealing with, and that is the subject, and which they call naturally it is beautiful and elegant. There is no doubt about it. But application part is also essential. So mathematicians usually may be considered as great scholars. I'm not saying their personality, but their what you call is a mathematical personality, which can be represented as a scholar and gentlemanly, who would indulge in the beauty and elegance of the subject. Mathematical physics, on the other hand, something quite different. Here, goal is slightly different. Mathematics used as a tool to solve the problems in physics, and that makes it is not the primary goal of our studies. So physics is a primary goal and mathematics is essentially a tool. So it's essentially a usefulness and application of which it matters, or the solution which matters rather than the elegance. Elegance, of course, is built in. Elegance is a personal choice. Something you may call elegance, something maybe not an elegance. So it depends on the personal choice. Now, mathematical physics can be intuitive. It need not be logical also. Now, there is a interesting thing here. So when you develop a solution, your thought or the procedure need not be logical or systematic. It can be purely intuitive. Of course, it can be logical and systematic too, but it is a result oriented. That means your goal is to solve a specific problem. You don't have to really worry about the elegance. Elegance may brought in. It is like a problem in an exam. When you have to write an exam, eventually you have to solve the problem. Time your teacher may prefer specific methods, but eventually or legally, it is suffice to have a solution. In the sense, elegance or how you have done, what kind of things which you have used, as long as you can justify that the problem is done by you and the solution is genuine, then you would get your mark. So that is a kind of a logic even in the mathematical physics. In short, mathematical physicists compared to an elegance view of mathematicians could be taken as a total freaks or crazy who do not respect or care or indulge in the beauty or logic or a systematic approach followed by the mathematicians, and simply make it an application oriented and look quite crazy for mathematicians. So mathematicians often dislike mathematical physicists just because it is not really in the proper spirit as per them. So mathematicians often dislike and would put in trouble by mathematical physicists. Because all this said, it is a mathematics which you are doing. You could have a logical way, you could have it. And often you find that as you go to advanced and advanced level, you would like to have a method, but more than that, you would like to have an intuition how a method can be obtained and how it can be used in understanding the physics. So that is a spirit in which this course also progresses. It is a solution which we are looking for. Let's take a quick example. Let's say that we want to solve a problem. We want to solve a differential equation. It's a fairly straightforward. D square y by dx square plus omega square y is equal to 0. You all know that if I ask you to solve a problem, I'm sure many of you even won't give a slightest thought about producing a solution to this and would simply write it down. I don't think it takes any time or any mental exercise or elegance or any sort of things which you talk about in mathematics to write a solution given by y is equal to a sine omega x plus b cos omega x. There is many reasons for this. You would simply write it down because this has already gone in your blood. So there is also this plot how this each function sine omega x and cos omega x looks like for omega is equal to 1 here, and then you can scale omega and all the thing you can do. A and b are constants, and then any solution is a linear combination of these two, blah 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 blah, you would know. Now what is trying to emphasize here is that the think of a time many years back for you, many decades back for me, at a time when you really did not know how to solve this equation. I even remember I did not even know how to solve it, but I knew the solution because moment I did not really know how to solve it. It is marked up, keep in your memory. That is why you reproduced it. You really didn't know it. Look at this equation. I knew that this has to be solution. We learned to solve it little later, but nevertheless use the solution. Now think of now, when I give this problem to you, if you would simply write down solution, there is a difference in your thought process between way you done long back when you didn't know and now you are doing. You are writing down the same solution. But in the second case is what we call is a mathematical methods of physics, because in between there has been a step where you know how to solve it properly using proper method of mathematics, algorithm used, how to solve this ordinary differential equation with constant coefficients and blah blah blah. All the procedures you have already done and understood, and it has gone into your blood. But now when you are asked to solve this problem, you would simply write down the solution. So that is a kind of a spirit of mathematical methods. It is not that you are skipping the hard work. Hard work has gone in somewhere in the backstage, and or you hide it purposely to show how smart you are and just write down the solution. Of course, sometimes you have to do the calculation depending on that. This is an example, and maybe replace it by with some other complicated differential equation for which you may or may not know solution. You look up, ask somebody, or you solve yourself. But don't tell it how you have solved it. You simply write down the solution. One can substitute back and check whether it is really a solution, and it does in fact work. And that is what you show, that it is a solution. So this is a kind of an approach. I will slightly switch back now to one of the greatest of mathematical physicists about the Dirac. Produced a function which is called Dirac Delta function, which is zero everywhere except one point. And at that point, you don't even know what is the value of that function. It is undefined. And the integral of that function over the entire domain is going to give 1, and it produces various properties of this function, and it has been extremely useful. Now, if you follow a rigorous mathematical steps to Dirac Delta function, you will end up in a problem, because it is zero everywhere and it is undefined at point, and mathematician would simply go bonkers on this kind of a thing, and that is what exactly happened. Mathematical physics, what we call is a Dirac Delta function, extremely useful in physics, quantum mechanics, and otherwise. It took quite long time for mathematician to understand this in terms of distribution function, maybe decade, and then they able to formulate rigorous and require mathematics for that. But mathematical physicists didn't wait for all that. They simply used the Dirac Delta function because it had all the properties and it gave the solution which is needed. So this is a main idea. Sometimes we just conceptualize or make an answers which satisfies to solve the problem, which mathematically may be acceptable or not acceptable. The consistency might be there. Maybe mathematicians don't really follow it in their rigorous framework because their attitude is quite different, and mathematical physics is quite different. So that is how the difference happens And the Dirac Delta function now is become a branch of mathematics by itself, which is a distribution function. So we'll not go into the details of mathematics of this Dirac Delta function. I'm sure many of you know, but we will get some details on that. Another interesting field where physicists have contributed in a big way is solving a partial differential equation. Partial differential equation essentially comes in terms of three or four main form, which is Laplace or Poisson equation, then diffusion equation, and wave equation. Mathematicians understand the Laplace equation very well, or Poisson equation. So that is basically a solved problem for them. And when you think of it, mathematicians often worry about the existence and uniqueness and all that kind of a thing, which is very important. This is important for physics too, but one often doesn't worry about it. The idea is, let's look at this del square phi is equal to 0 Laplace equation. We can take it as a solution to electrostatic potential or gravitational potential. So you see that physicists' way of understanding the uniqueness of the solution goes like this. It represents the electrostatic potential. That means we know that if you go and measure electric field, then you get a unique number. At a given point, if you measure electric field, it gives a unique number. It doesn't give two numbers at that point. So the solution have to be unique. That is the way physically you think. On the other hand, uniqueness is also essentially means same thing. So that is why you don't really care. Your goal is to solve this equation and get the solution. Of course, one of the problem is a wave equation. Wave equation is a fairly complex from the mathematical perspective, but physicists somehow solve it in a magical way. Don't really care about many details. You will have to ask mathematicians the complexity of the wave equation, which none of them worries. Physicists simply solve them and look at them. So we will have some of the way to see them in this course. In continuation with this, I'll show you another small video. It gives you a puzzle or a problem. Three friends went for fishing to a river. They sat there and fished for a whole day. They piled their catch and had a fun on their own. Soon it became dark and they decided to take rest and sleep there only. In the middle of night, one of them woke up and could not sleep. He decided to go home without disturbing other. He decided to divide the catch equally, but one extra fish remained. After giving some thought, he decided to throw the extra fish into river. He walked away with his share, leaving out the pile. After a while, the second man woke up. He too couldn't sleep there in the wild, so he decided to go home without disturbing others. So he decided to split the pile into three equal parts. Once again, one extra fish remained. This time, he threw that extra fish into river without giving much thought and walked away with his share, leaving out the pile once again. The third man could not sleep there too. He woke up without realizing that other two has already left, and he decided to go home too. He divided the pile of fish into three equal parts. Once again, one extra fish remained. He threw that fish into river. Taking his share alone, he walked away, leaving out the pile. Now the question is, how many fishes were there in the pile in the beginning? How many fishes were taken or carried away by each person? And how many fishes were left on the river bank? Let me stop for a while here and we can have a discussion on the solution of this problem. So if this is an iterative procedure and one need to find out the solution, how would you proceed and what would be the solution? Anyone want to go about it? The discussions are an important part of this mathematical method. So in a large class, I believe that you guys simply want to vanish in the background. So that is why I divided entire class into smaller groups, and so that we can have a closer interaction. Because certain topic may be covered, may be not covered, but one has to get the habit of solving this problem and having a proper discussion on each of these issues. Basically enhances your understanding, or it helps you to clarify your own thoughts. So here idea is that you have a number which is not divisible by 3, and there is a remainder which is 1. So you subtract that or throw away the extra number which is a remainder, then it is divisible by 3, and then you take 1/3 of it and 2/3 of it would remain there, and it should go, the remaining 2/3 should again go through this detailed iteration. So one can formulate this. You start with the initial n number of fishes, then you can say that n is not divisible by 3, but n minus 1 is divisible by 3, and then so on. You can do it and try to solve it for consistent number and so on. But is there some quick answer in the spirit that you are not really writing down anything and try to do a quick mental calculation and see whether you can solve it, whether you get a meaningful solution to this? You don't have to get to a solution. Is there some thought on this problem?
Kindly repeat that after divisible by 3 part.
Yeah, no, I was telling an algorithm. If you are a mathematician or if you want to solve, put a pen and paper together, you know that there are n fishes there. N is not divisible by 3, because if it was divisible by 3, the job would have been very simple. You divide the number of fishes into equal 3 places and take your share and go away. That is 1/3, and leave out 2/3. There was one extra fish left out, which was thrown into river. So n minus 1 is divisible by 3. Okay. So then n minus 1 is divided into 3 equal parts. 1/3 of that is taken away, and 2/3 of n minus 1 is left. Now the second person gets up, repeats the same thing, but now it is with the n minus 1 by 3, 2/3 of n minus 1. He does repeat same thing. It looks like it gets into some series and it has to terminate at some stage. It looks like a fairly complicated problem. Of course, you cannot have a real number. Solution have to be integer because it is a fish. Yes, that is a procedure. This is exactly what I am discouraging. It is not in the spirit of mathematical methods. The mathematical methods is someday getting the solution. If you do it, it gets complicated. It looks like it is a never-ending solution. It is possible to solve it that way. I am not saying that it is not possible. The reason for this is that this has an elegant solution. It's very difficult to describe how you come across, but one person, in fact, has quickly come up with a solution. I'll give a few more minutes to digest this. I have had a tutorial problem, but somehow I don't think it is possible to do tutorial. Let's see whether we get across this message of mathematical method. Anyone? You say that audio is not clear. Okay, let me repeat the story. 3 people go for fishing. They catch fish throughout the day. They pile up. It becomes an evening, and then they decided to sleep. It is in the wilderness and dark and maybe noisy in the forest or whatever. Maybe mosquitoes were biting, insects were chirping and all that thing. So one of them gets up and decided that he don't want to suffer all that. He want to go home and sleep on his nice bed. So he decided to take his share. So he looked at the fish, divides them into equal 3 parts. Then he found that there is a one extra fish because it couldn't be divisible by 3. So there was a remainder 1. So he gives some thought. He didn't know what to do with it. He simply decide to get rid of the problem by throwing that into river, and then divides the remaining fishes into equal part, takes his share, but that fellow simply piles the other 2 share together and leaves. It's a dark, and other guy also could not sleep. So he did not know that his friend has left. The second person also decided to go home. He had enough of this forest. So he comes to the fishes. Then he sees a pile of fish there, try to divide the equally into 3 parts, and then it doesn't work out. There was a one extra fish. So he also, they are all friends. You see that they must be thinking alike. So he also decides to throw the extra fish into river and then divides the share equally into 3 parts again, and then takes his share. Again, they are like-minded friends, piles the other 2 share together and leave. Now it turns out that it is an iterative process. It doesn't matter. The other 3 now are disjoint. If whatever one does, others will not know. So it is an iterative process, can go on infinite. You can narrate this story with forever. Now question is how many fishes were there and how many fishes each one took. It's a classic example of a problem in mathematical methods, whether you should use a rigorous procedure, whether you should use a trial and error, or whether you have enough intuition to solve it directly and give the solution. Okay, so don't
So
worry if
we
you,
have to,
yeah, go
so
ahead.
maybe we have to try with different values by
Yes,
putting.
yes, that is a one way, trial and error. See, that requires a quick calculation in the mind. You put a number 0, 1, 2, 3, and so on. You check, figure out what happens, and quickly come to a conclusion what should be the solution. Don't worry too much about if you have not managed to solve this. So the
Sir,
problem, yeah,
sir, we can do it this way that since there are 3 people and every time we divide by 3, there's it's like that number is not the remaining number is not exactly divisible by 3. So we have to consider a number which when divided by 3 will give us a number that is not divisible by 3, but if we divide it by 1, so like in case of 40, something like 40 divided 40
yeah.
minus 1 divided by 3 will be 13. 13 minus 1 is again divisible by 3. 4 and
Yes,
4
I
minus 1 is
agree with you. I agree with you. See, but let me bring fallacy about what you are trying to give me is a method. Okay, I am not interested in method at all. I just want a solution, right? This is what we are looking in mathematical methods. It is mathematician job to develop a method, systematic algorithm, try to see it, what is a solution, put a constraint. All these things can be done. You can spend hours doing this. It might have a, one of the mathematicians once said that mathematicians save a lot of time by giving method. Because if problem has to be solved 1,000 times, then each one trying it to solve would be a lot of time spent. One mathematician develop a method to solve a problem, and 1,000 people can apply and solve, get the solution, and all the time individual trying to solve it is saved. That is a basic philosophy of pure mathematics. We have enough time and we have a problem, and I just want a solution. I don't care whether you develop a method. I don't care whether you do trial and error. I don't care whether you ask somebody and get the solution and whatever. The question is, at this stage, what is the solution? That is a spirit. I'm not discouraging you developing a method, but that's not the spirit of this course. Of course, throughout the course, we will be learning techniques, method to solve problem, but eventually goal is to have a solution. So let me continue with the presentation. This is a important part of discussion. So interestingly, solution to this is called Dirac solution, or one says the Dirac gave the solution to this problem. I am not too sure whether Dirac really gave this problem or whether it is just the spirit of this is called the Dirac solution. The solution to this problem, at least one of the solution to this problem, is n is equal to -2. So this is a stumbling block here. The idea here is that sometimes physicists have this mental blockage for a mathematical solution, expecting a physical solution. You put a constraint on yourself, expecting a physical solution and not finding it. It's n is equal to -2 does not make sense. Does it make sense? No. What is a -2 fishes? -2 fishes does not make any sense. But let's look at it mathematically. -2 is not divisible by 3. So you have to subtract 1 from this. So that is -2 minus 1 is -3. Okay, now you divide it by 3, so you get -1. So the first person goes away with the -1 fish, and then he leaves -2 fish back. The second person again sees -2 fishes. He repeats same thing. We know that the negative fishes doesn't make sense, but for Dirac, it indeed does. Now, this is where the Dirac first proposed the anti-particle theory based on the negative solutions. Now, if you had gone by purely your intuition or physical sense of intuition, demanding the physically genuine solution, you could have missed it completely because negative solution did not make sense. But Dirac did make sense of this. I am here not telling against mathematicians. You can develop a method and exactly solve it. Probably you would get a -2 solution, and physicists would simply throw it away, telling that it is a meaningless solution. But Dirac did make sense of exact mathematical solution and then ended up building something very remarkable physics out. So it is often interesting that how a mathematical physics topic should be treated is extremely delicate. You would have all the procedures. You may follow, you may not follow. You may rely on your intuition, get a solution, and sometimes you may throw out the solution because it does not physically make sense. It sometimes is a wise thing to do, sometimes it is not wise to do. So sometimes you may be throwing out things which are genuine and holding on to something which is routine. Now here is a thinking process in which it is purely built on experience or whatever. You need to have worked out solutions, whatever it is, you need to work hard. Dirac is a extremely systematic person who has contributed enormous, both in an intuitive and counterintuitive sense, to the mathematical physics and to the physics and mathematics itself. So here is a major boundary, which is a negative energy solution. So there are these two aspects. Physicists often say that the solution have to be physical, or it has to have enough physical understanding. It sometimes intuition can take you to be a great physicist, or you can be called a genius, or sometimes you could become a laughing stock. So one has to see and accept both this idea which comes with the mathematical methods and be ready for this. And that is a basic idea of mathematical physics. Okay, so let me stop here. And if you have some questions and any discussion, we can have. Any questions?
So a little question.
Yeah.
Sir, now we have -2 fishes.
Yeah.
And first person wakes up. He throws one fish in water, and
Yeah.
then he takes out one fish. That is
-1.
1/3 of whatever it is. So
No,
it should be
minus.
-4 fishes.
No. He takes the -1 fish.
So the -3 -1 is -4, right? I mean,
No. See, let do this calculation more carefully. you had a minus 2 fishes. Okay, one fish is
Yes.
thrown out into river, so that you subtract one. Okay, so
Hmm.
that means
Okay.
minus 3 fishes. You divide them equally. Okay, now individual share is -1. Now the
Ach-
first person takes -1 fish away, so you have left with -2 fish there, or no, -3 fish. Out of -3 fishes, you take -1 fish. That means you subtract -1 from that. Minus minus makes it plus, right? So that makes it -3 plus 1. So remains the -2 fish again.
Okay, sir. So
So
then
now,
why that minus minus plus becomes while we are throwing a fish into water?
no, he throws away positive fish.
Then how come he take a negative fish? Why cannot he take positive fish only?
No, there is no positive fish there.
Yeah, acha, okay.
See, the basic idea here is that you are producing a solution of -1 to number of fishes. Okay, this is exactly concept which Dirac used for his relativistic solution of negative energies. And it's not really negative energy state, which is called, but it is antiparticle. Okay, so
Acha.
there is a sea of, think of a neutral sea as a positive, a neutral universe, you call it, as negative and positive fishes in equal numbers, and overall it is neutral. Okay, now if you
Yes.
take a one positive fish away from this bucket or tank or whatever, now you will have a positive fish, but there will be a negative fish in the pond swimming around. Okay, the reverse
Okay.
also could be done. You could take a negative fish from the pond, then the real positive fish will be swimming in that. So that is what is actually particle and antiparticle idea, right? You can have an antiparticle. So that is exactly the negative number. So you have a, it's kind of a fallacy. The whole thing is constructed, I believe, is how can he throw away a fish into the river when there are only negative fishes? You may ask that. That's a genuine question. But this is only an idea. You have been given that it is, there are two negative fishes, and then he pulls out the positive fish and throws into river. But in your ensemble, because you have thrown out the positive fish, there should be a negative fish left there.
Okay. Thank you, sir.
Okay, I think time has become. So next week onwards, we will follow this shorter ensemble. I will put some videos meanwhile. Irrespective of that, we can have a discussion regarding any mathematical physics topic.